In this module, we will learn about the fundamentals of thermodynamics and terms associated with it. Before we begin, let's look at examples of some common chemical reactions, like the burning of coal. When coal is burnt, the chemical energy stored in the molecules is released as heat or thermal energy. Another example is that of burning of fuel in a car engine. When the fuel burns in an engine, it converts the chemical energy to mechanical energy, propelling the car to move along the road. In both the examples, chemical energy, that is the energy stored in the bonds of atoms and molecules, is converted to other forms of energy. Thus, various forms of energy are interrelated, and under certain conditions, these may be transformed from one form to another. The branch of science that deals with the study of different forms of energy and the quantitative relationship between them is known as thermodynamics. The term thermodynamics is derived from the Greek word thermos, meaning heat, and dynamics, meaning flow. It was coined by James Joule in the early 19th century. Thermodynamics deals with the energy changes within a system. A system in thermodynamics refers to that part of the universe in which observations are made. For example, the tea in the teapot is a system. The part of the universe that is not a part of the system but can interact with the system is called a surrounding. In this case, the room in which the teapot is kept is the surrounding. Systems and surroundings together constitute the universe. The part that separates a system from its surrounding is known as boundary. In this case, the wall of the teapot is the boundary. Note that a boundary can be real or imaginary, and it controls the flow of energy and matter into the system or out of the system. In thermodynamics, based on the movements of matter and energy between a system and its surroundings, systems can be classified into three types. These are open system, closed system, and isolated system. Let's look at each system. A system is said to be open if it can exchange both energy and matter with its surroundings. For example, tea becomes cold when left open for some time in a container as a result of exchange of energy with the surroundings. At the same time, some amount of tea escapes from the cup as vapor. This is because of exchange of matter with the surroundings. Hence, this is an example of an open thermodynamic system. A system which permits the exchange of energy but not the exchange of matter across the boundary with its surroundings is called a closed system. For example, if tea is kept in a closed steel teapot, it takes some time to cool down. This indicates that energy is exchanged with the surroundings. However, as vapor cannot escape from the container, no exchange of matter is possible. Hence, this stands as an example for a closed thermodynamic system. A system that can exchange neither energy nor matter with its surroundings is called an isolated system. For example, the tea kept in a thermos flask remains hot and the vapor also doesn't escape out. This is because neither matter nor energy can be exchanged with the surroundings. Hence, this is an example of an isolated thermodynamic system. You have now reached the end of this module. In this module, you have learned that the branch of science that deals with the study of different forms of energy and the quantitative relationship between them is known as thermodynamics. A system in thermodynamics refers to that part of the universe in which observations are made. The part of the universe that is not a part of the system but can interact with the system is called surroundings. The part that separates the system from the surroundings is known as boundary. A system is said to be open if it can exchange both energy and matter with its surroundings. A system is said to be closed if it can exchange energy but not matter with its surroundings. A system is said to be isolated if it can exchange neither energy nor matter with its surroundings.